Tapioca, also called as cassava and in some place kappa, is a major source of starch production. About 30 million tons of starch is produced and used for various industrial purposes, right from textiles to paper making and even making certain kinds of food product. But then there is a major problem in this industry. Cassava has very little shelf life. Within 2 days, it starts degrading. If you can extend the shelf life of cassava, then perhaps the farmers can benefit more. They can get little bit more income. Our guest today, Dr. James George, Director of Central Tuber Crop Research Institute, Thiruvananthapuram, a constant unit of Indian Council for Agriculture Research, is engaged in this question.
Dr. James George is presently heading the ICAR-Central Tuber Crops Research Institute situated in Thiruvananthapuram. He has more than 26 years of research experience in tropical tuber crops. Dr. George has obtained his PhD in agronomy from IIT Kharagpur and has extensively worked on tuber crops agronomy. He has also developed many agro-related techniques, where mini-set technique is the most popular. Dr. James George has about 90 scientific publications to his credit and also recipient of several outstanding awards.
Thank you, sir. Thank you, sir, being with us in this program. We are profusely thanking you for sparing us this time.
Thank you for being here. Thank you.
Let me start with one interesting aspect of your research. We'll come back to this cassava a bit later, but then let me start with another point, which is mini set. I mean, you have developed a new method of producing saplings and maybe propagation method for tuber crops. Can you explain us what it is actually?
In tuber crops as such, the multiplication ratio is very poor, extremely poor. For example, in cereals, so when a grain of rice is planted, some 80, 100, 120 grains are produced out of it. Yeah. Whereas when we plant a tuber crop mother corm or a mother set, say for example if it is cassava, one small set when planted, from two stems will be produced. Each stem only 5 cuttings can be taken.
Okay.
So it is almost 1:5. If 2 stems are there, then 1:10. Compared with the cereals, it is extremely poor. Whereas when we talk about some other tuber crops, like a corm, the Amorphophallus or elephant foot yam, the multiplication ratio is only 1:2 or 1:3. In yams, it is only 1:4. So compared with all other crops, the multiplication ratio in tuber crops as a whole is extremely poor. These are all vegetatively propagated, clonally propagated.
So basically, which means that you take a corm and then plant it. Like say if you want to produce potato, you actually plant a potato, not some potato seed.
Exactly.
That's
exactly.
right. Yeah.
Exactly. So what happens is, since the multiplication ratio is poor, 3 major problems are associated with this. One is, since this is vegetatively propagated, as I told you, the mother corm that was once used, the same stem or the same set that was originally used, although it generates a new one, but the parentage is the same. So from generation unto generation, the same genetic transformation happens. And the process is that over a period of time, the degradation of the quality happens, and added to that, the the disease problem. It catches a lot of diseases, virus diseases. And once it is caught with the parent material, it is again transferred generation to generation. So in the process, the stem or the mother material, the planting material that the farmer use, it becomes diseased and totally unproductive. So this is a major problem. The second problem is, of course, the second problem I should say that it's a disease problem. The first one is the poor multiplication ratio. The second is the disease problem that is passed from
Yeah,
generation
sure.
to generation. And the third problem is the bulkiness of the planting material.
Yeah.
If a farmer has to plant, say, half an acre of a rice paddy field, he needs only a half bag of or a 500 gram or 600 grams of rice grains.
Yeah, that you can carry it as a bag.
In
I
a
mean,
small
seed,
bag
yeah.
or a pouch he can carry. Whereas if he is to plant even 1 cent or say half an acre, he has to transport the planting material in a truck invariably. There is no other means of transporting.
So
from the
basically, if you are going
resources.
to plant a yam, you
Yeah.
have to carry the whole yam.
Exactly.
And if you want to plant, let's say, about 10,000 yam, then you have to carry actually 10,000 yams to your field. That's a major problem.
Exactly.
Yeah.
So the bulkiness coupled with the transportation is a cost adding factor. So the farmer at the end of the day will not be benefiting anything because the cost of planting material itself will be a huge amount that he will incur. So these three are the major problems associated with it. So we have been thinking on how to minimize this particular issue. Then back in 2002, with the help of the NATP program under the ICAR, in which I was the principal investigator, we started working on this particular issue. And till about 2006-7 we worked, and we came out with a technique called mini-set technique.
Mini-set technique.
Mini-set technique, whereby the size of planting material has been drastically reduced.
So you don't have to plant the whole yam, but leave only a small portion of it.
For example, in Amorphalus or elephant foot yam, 1 kilogram was the actual planting material size traditionally used, which I have reduced to just 100 grams. 1/10. 1/10 only. In cassava, it was it was a stem of about, say, a set of about 15 centimeter long or 20 centimeter long, that I have reduced to just 2 noded sets. That is what it is called as mini set. So in yam again, the usual planting material size is 250 gram, which I have reduced to 30 gram. So in all this tuber crop, we have reduced the planting material. And the philosophy behind it is, the size of the planting material actually doesn't matter for the generation of a new sapling. Because whether it is 1 kg material that we plant, or it is a 100 gram or a small minuscule that we plant, the mother corm that we use is only for generating a new propagule. In other ways, the mother corm that you plant is actually a stored food material for the new sapling to emerge.
So it's like, for example, a chicken growing inside the egg.
Exactly.
It uses the yolk to grow.
That's all.
But after it grows, you don't
It's
need
on
it.
its own.
No.
The same way, once the rooting happens and it strikes the soil, in the first go itself, the drawing of food material from the mother corm stops then and there.
Okay. The moment the roots from the daughter plant
Yeah.
touches the soil,
Yes.
the
It's-
connection kind
the
of...
connection cuts off and it starts drawing food material from this soil. Nutrient, water, everything is drawn from the soil. So this immediately becomes a new plant material, a new material, which has put forth its root, and it starts shooting up also. The shoots will emerge. So a new life actually.
So basically, you optimize what is the mother plant amount that is required
Yeah.
till the shooting takes place.
Yes.
So, I mean, maybe some plant the shooting may take place fast, some plant it may take slow, but then you look at all of them and then find that this is the optimum size and beyond which it's actually not needed for.
In this long period of time, we actually standardized these whole issues. And then we standardized, because one of the major apprehension or question asked was that a new plant that you get out of such a small minuscule mother material,
Will it be strong
will
enough?
it be able to withstand the rigors of the climate, the water stress, all the kind of stress that is exerted upon the plant, the new growing plant? Well, from the experiment that we conducted, we found that once we give a very ambient condition in the soil as well as in the atmosphere, the plant will easily grow and thrive. In fact, it is only the soil that you need to take care, because the temperature stands the same for everything. If you adequately give the nutrients to the area where the plant is growing, and if it is kept moist to the extent that the plant requires, I can assure you it will give a moderately good yield.
Very interesting.
But my focus is not on the yield as such. The major focus is on quality planting material production. So since we are looking for more number of planting material, this is an ideal way. And apart from that, I have manipulated the the technique part of also. For example, the cultivation part of it. Say for instance, cassava is planted at a spacing of 90 centimeter apart. Whereas this mini-set material that we developed, we have given a smaller spacing or a closer spacing. It can be grown at a spacing of 45 by 45 or 1.5 feet by 1.5 feet. So for a small scale farmer who doesn't have a large acreage, this is an ideal way of cultivation whereby twin objectives are met. One is more production per unit area and more number of quality planting material.
Yeah, very interesting, and we are having a very interesting conversation, but then we need to take a very small break here now. We'll take a very small break. Don't go away. Keep watching Eureka. I'm going to ask him a very interesting question after the break. We know yam is a tuber, potato is a tuber, but is carrot a tuber? How do you distinguish? We'll ask this question after the break. Don't go away. Keep watching Eureka. Welcome back to Eureka. We are having a very interesting conversation with Dr. James George, Director of Central Tuber Crop Research Institute, Thiruvananthapuram, a constituent unit of Indian Council for Agriculture Research. Before the break, I promised the viewer that I'm going to ask you a very interesting question, maybe in most of our mind. We know, or we call potato a tuber, maybe yam as a tuber. Okay, there are many other tubers that we know of. But then what about plants growing below the ground, like for example carrot or other materials? We don't call them as tuber. How do you distinguish between them?
It's a very good question, very interesting also. We actually deal with tropical root crops, root and tuber we call it, root crops. Root and tuber crops. And all these crops that we deal with are basically either tropical or subtropical. It doesn't come up in the temperate region. Whereas potato is, although a tuber crop, it grows in the temperate conditions. Of course, now our institute in Shimla, which deals with potato, they are working on potato which can be grown under the drought condition or even under the temperature condition. They are working on that. But basically, it's a temperate crop. Now, the difference is, potato is actually a modification of stem. Whereas most of our crops are root crops basically, although we have exceptions like Amorphophallus, which is a modification of rhizome. It's a rhizome actually. But when we talk about carrot is actually propagated through seeds.
Okay.
Not through root or that kind of
okay. It's not a vegetative propagation.
The clonal multiplication that we deal with. So it is not categorized, although it grows underneath the soil, it's not strictly categorized under the tuber crop or tropical, subtropical tuber crop. It doesn't come under. It's more or less a vegetable. But our crop that we deal with are not just vegetable crops, they are food crop actually, most of them. See, sweet potato, once upon a time, it was a very important food crop in many parts of our northern India. Cassava is a major food crop in many parts of Africa and South American countries.
So basically, food crop is one which you use as your staple food. Like say, for example, rice or wheat or a maize, you use it for your bulk consumption. That is the kind of, very interesting point. I mean, I think we got some interesting understanding from this. I would like to go back to your earlier times. You know, one of your PhD work, from which your career in agriculture research started. It is related to using industrial waste to benefit agriculture. So, can you explain to us? I mean, like, I believe you worked on fly ash, right? So, fly ash near a thermal plant is a waste. But then you say that the waste can become a wealth if it brought to a different place.
I was fortunate enough to do my PhD in the Indian Institute of Technology, Kharagpur, under a great scientist called Dr. B.N. Mitra. B.N. Mitra. That was the time when he was working actually on fly ash. When I joined as a student, then he suggested that why not we work on this fly ash with your crop, the crop of your mandate, which is tuber crop. So I selected sweet potato, and sweet potato is actually consumed by people. So fly ash, as you rightly pointed out, it's a major nuisance, especially a pollutant, atmospheric pollutant, not only atmospheric, even soil and water body pollutant in areas wherever thermal plants are there. Usually it is used as a land filler and that kind of thing. Even as a filler in the fertilizer they use it. But how effectively this can be used in agriculture? That was a major concern. Now this fly ash has a lot of micronutrients available in it, like sodium, like boron, manganese. All these are available. These are essential for the maintenance of the soil health as well as for the plant that grows. But the dosage is very important. So in my experiments, we tried with different levels, dosages of the fly ash application into the soil, and then its behavior in the soil was studied. How much of it gets actually drawn up, or these so-called heavy metals, if at all there are, how much it gets drawn up into the plant system and into the tuber, and is it at an alarming level? And at the end of the day, I found that this can be very effectively used if it is applied to the extent of about 5 or at the most 10 tons per hectare at a desired level of application, not regular application, maybe giving a 1 year break if it is applied. Then it is an excellent storehouse for the addition of micronutrient into the soil, as well as an ideal material as a soil ameliorant. Many of our soils are acidic, and this is almost neutral, or sometimes a little above the neutral level of the pH status. So thereby addition of this, we have found that
it heals the soil.
acidity level could be a bit raised in several areas, especially in our tuber crop area. And then the yield was triggered. So we got a very good finding that day, and the kind of apprehension about the heavy metal, that was absolutely not there. So this can be used, but again I would caution, this has to be used very discriminately, not indiscriminately.
Yeah. The other area that you are also known for, one of the major contribution individually and also as an institution is to evolve a standardized practice for tuber crops.
Yeah. Yes.
So what is it?
As at the outset, I told that all these crops are traditionally cultivated either in the kitchen garden or in the courtyard of farmers, except in a few states like Tamil Nadu and Andhra Pradesh, or in the West Bengal in some area, Orissa, of course, sweet potato and yams are grown on a large scale. In most of the other states, especially in Kerala, it's grown in homesteads only. Now, when you grow in homesteads, people always use the traditional package. People seldom use nutrients or the fertilizer, chemical fertilizer was seldom used. So the result was the yield was comparatively less. So we found that it is, in order to attract more people, especially in the industrial belt, in order to attract people, we need to tell them that if you add this or this, if you follow this particular package, this is the kind of yield that you are going to get, and definitely this is the kind of returns that you are going to get. So we developed agro-techniques. We decided on what should be the size of planting material, what should be the spacing, what should be the type of fertilizer that the farmer should add, what is the kind of organic material that he should add, and what is the dosage of irrigation that he needs to give. Because in Tamil Nadu, I found that people would flood the field right from the morning till evening. The water will be flowing, and it's a wastage. So they need to identify. So all this was identified and we standardized. So that is called as agro-techniques. The optimum standardized package of practice that is recommended to the farmer.
For all the tuber
For
crops.
all the tuber crops we
Except,
could
of
do,
course,
and we have given it as a package of practice. In fact, the university, the Kerala Agriculture University, has brought it out in the package of practices, most of this.
Very interesting. Thank you. I mean, we'll take a very short break now. Don't go away. Keep watching Eureka. Welcome back to Eureka. We are having a very interesting conversation with Dr. James George, Director of Central Tuber Crop Research Institute, Thiruvananthapuram. We had a very interesting conversation before the break. Let me go back to even earlier part of your time. How did you land up in this job?
It's a very interesting question. I never actually at any time thought of entering into agriculture research. In fact, when I was in my intermediate, I had different plans, different dreams. But when that did not materialize, my brother, who was then in Allahabad, he suggested that there is a very good institute at Allahabad called, then it was known as Allahabad Agriculture Institute. Now it is a deemed university called SHIATS. He suggested that why don't you come and study here, agriculture. It has a lot of potential. The thrill of going out of my state and to be in another state, I thought that, yeah, why not try this? So I went with that idea only. But once I entered into this system, after my career, I did well in my all through I had a very good grade and I did well in my studies and I developed an interest. It actually gave me an insight into the farming scenario in the country and the poor farmers of the country. So I thought that this is where the destiny has led me, and I started developing an interest.
Very interesting, very interesting. I mean, maybe accidentally you entered into it, but then you found it passionate, and then you're passionately doing it for more than 3 decades now.
Exactly, yeah.
Let me ask you one question. You're also heading this very important institute, Central Tuber Crop Research Institute. If I ask you, what are the 3 major challenges, research challenges that this institute is facing today? What will be your...
Thank you. That's a very interesting question because, in fact, we have been contemplating upon these issues. In fact, when we have been asked to project our plans for the 2030 and 2050, this is what I am going to suggest is what we are actually going to focus on. As I discussed, we have standardized the technologies for the raising the crop and stabilizing the yield, but then we are developing new varieties, looking into the challenges that we have. We are living in an era of climate change. Now, the tuber crops are known for their climate change resilience. And by 2050, it is predicted that the temperature is going to rise by another 2 degrees.
Yeah.
So, the present state of affairs and our happy and content life with rice and wheat and all these cereals probably is going to run into a casualty. In such times, tuber crops are going to come to the help of the Indian masses. So, we need to focus on that, keeping 2050 in view. We need to work out in our different experimentation to see that when the temperature keep rising and the atmosphere conditions change, how best our crop could respond to the challenge. Okay. We are studying on that particular focus.
That's one.
That is one important challenge.
Second is perhaps increasing the shelf life of tuber crops.
The second thing that I want to say is, as you pointed out, the shelf life of this crop. In cassava, it's a major issue. It's very poor, hardly 2 days. Then the starch gets broken down, chemically that composition breaks down and it degenerates. It gets decaying, the decaying process starts. And once the quality deteriorates, it's no use, neither as a food crop nor as a material for the industry.
And also, if you can increase the value addition at the farmer level, that will be another major challenge, right?
So, the second issue is we need to address this major problem of enhancing this shelf life of all the tuber crops. We have basic problem with the cassava. At the same time, we have issues with other crops also. So, we are focusing on this particular aspect. The third aspect is value addition. By value addition, We have already started it. In cassava, we have brought out several products, huge number of products. And the farmers have been attracted in a large way. We have also started an incubation center where farmers come, they are given training at the outset. Then once they get interested, they come back, and then they are given the provision to stay here. They can bring their own material, use our equipments, they can develop a product that we have taught them, and then take it out and sell it in the market and see for themselves. If there is a good response in the market, then only they can start a venture on their own. So in order to avoid the risk involved, we have started this incubation center.
So this effort of yours would also promote some kind of a rural agriculture-based industry, correct?
Exactly.
Yeah.
Now, already some 10 people have already started their own initiative. One person has started in a big way. It's known as Tierra Foods, a place called Adur, which is about less than 100 kilometers away from here. The products that he has actually, it's equivalent, if not better than the potato product Lay's that we get in the market. Better taste, better crispiness. It's getting a huge market, very important market response it is getting.
And tuber crops are also used as an input for producing bioethanols, right?
Yes, yes. Now, this is another important challenge, maybe the fourth one I'll say, the fourth one I'll add. The fuel, the fossil fuel is going to be a major issue in the days to come. We are all aware of it. Now, cassava, we have although standardized about 30 years back, ethanol production, bioethanol production from cassava. But that was a fermentation technology that we use, which was in fact costlier than ethanol production from molasses of sugarcane. So it actually did not click. But of late, we have been able to develop a production of ethanol through enzymatic measures, and that is very cost effective. Now, China in fact has gone a bit ahead of us. They have already started producing in large scale in their South China provinces like Hainan and all. Although it doesn't grow, this crop does not grow much in South China, what they have done is they have leased out lands in Laos, Cambodia, etc. So we have to compete with them.
Thank you. We had a very interesting conversation with Dr. James George, Director of Central Tuber Crop Research Institute. And look at the possibilities that it provides. India still is an agriculture country, and we need quite a lot of research in agriculture, and this kind of institutes provide you great opportunities. Use these opportunities and keep watching Eureka. In the next episode, we'll interact with another scientist in another episode. Thank you.